Hi, this is Brent with Theoretically Practical again, and yet another video on welders. But this is a different welder, and this is probably the last or second or third or fourth to last video on welders that we'll probably do on this channel for a good long time. This one is about my TIG welder. This is a, I want to say it's a 1986 or 87 Miller Dialarc 250 HF. I think if you're a home garage guy and you want a professional quality MIG welder, you could do a lot worse than this unit. What I like about it is it's 250 amps, which is great. It's AC, DC plus, DC minus. But I don't think I've ever actually used DC plus, except for maybe stick welding. It's got post flow time. It's got the high frequency start, off, and continuous, which you would use for aluminum. Remote contactor, remote all that stuff. I got this welder with, it's also single phase, so you don't have to spend a whole bunch of time converting it. I picked up this welder with everything I needed to make it work, except this regulator, which you can get on eBay for about 25 bucks, it's perfectly good regulator. And it didn't come with a power cord. And I picked that up for $600, all the cables and everything. And I would suggest with buying older welders, if it doesn't have the foot pedal, if it doesn't have the TIG torch, if it doesn't have the ground, if it doesn't have the stinger, just pass it up. Because it seems to me that the price of the unit doesn't actually change whether or not it has all the accessories. But each one of these accessories, this TIG torch is like 150 bucks to replace in a reasonable way, which I just smashed the end off it, which is great. You know, a ground connection doesn't seem like much, but $30 or $40 anyways. The foot pedal, which obviously you can see I treat mine very well, is almost unobtainium. They do last pretty much forever from what I understand, but if it doesn't have a foot pedal, for this particular unit, they're, $200 or $300 on eBay. So like if you get it with all the bells and whistles for 600 bucks, that's great. If you got it for $400 without them, you'd be doing a lot worse. So, take a look under the cover here. So this is interesting. With a TIG welder, you do have a contact right there that you need to maintain at about an 8 thou rating. You refer to the instruction manual, which Miller is super good about having every instruction manual for every welder from all time. So remote amperage, remote contactor, water in and out. That's only if you have a water-cooled torch. I have an air-cooled torch. Let's see, overload breaker, 110 power source if you needed it. Gas in, gas out. So that's where that regulator attached to the gas out goes to here. That's the torch, and that's the where the power goes into it. Something to note about this, mine has the stinger for stick welding, which is great. What I didn't really think about is right there, it's attached. It's also attached from the TIG source is. I used to leave it clamped right there until I realized that the case is grounded and that's hot whenever you TIG weld. So, yeah, so, after that I clipped it somewhere made out of rubber. I am going to today be putting this on wheels and putting a cord on it, and so that both of my welders will use the same outlet and I can roll them around and get them out of my way when I need to, because this is another 300-pound monstrosity, but it's super reliable and it does a really nice job for what it is. So this is the inside guts of it. You can see that it's for single phase because you only have 1-2 power inputs in that, but when you go to wire it up, there is this on the inside cover, and that right there tells you, see jumper there and there for 230. Let's see if I can get a little closer. There we go. There and there for 230. If it was 460, you'd connect on the in there, and then if it was 200 volt, you'd connect the two outer ones. So there's these maps on almost every welder to show you the voltage that you should wire it in for, and this one was pretty simple. So again, I'm wiring it for 230, so you see I put a jumper there and a jumper there, and it's ready to rock and roll. And then the ground attaches to the case. So what I want to do is attach wheels to it. I want to, I only have a small argon tank because I don't go through it that often. 3 to 6 months, because again, I work full time. This is just in my shop, so this is much easier for me to do, and the local auto parts place will swap the tanks for me, which is probably way more expensive than it should be, but such is life. So what I have to accomplish that with is, this used to be for my 140 my Hobart 140 welder. I used to roll around this, but now I have it in that gray cart there, and it's a lot better of a situation for it. It fits under there nicely. I kind of, I wouldn't put tools or anything down there because you got to bend over every 30 seconds to pick them up. So I've got this thing here. It's got these great big wheels on it, which obviously are nice. I got the chain for the to loop for the argon tank, which is nice. And then actually the whole framework of this upside down is probably a really good little tray to put back here for the argon tank. Just like there's a tray back there on that one, I could put a tray here. One of the other reasons I'm doing this is because I got a bunch of scrap aluminum diamond plate. I'm going to make a box for the capacitors from the last welder. So that should be covered up nicely and, let's say reasonably safe. So yeah, I think that's going to be my tray flipped upside down and attached to the end of it. I think I need to go to Home Depot and see if I can get a piece, or Lowe's. I think our Home Depot is better than our Lowe's. See if I can get a piece of rod in that diameter that's as wide as this welder is. And then my front casters, I don't think I'm going to use all of them, but I bought 4 casters like this, which were the largest ones I could reasonably get. I think they were like 300-pound capacity each. But I think I'd much rather use those great big wheels, at least on the back, and then a pair of these, but the swiveling ones on the front. So a tool that everybody with a garage or a home workshop or anything should have is one of these. Dial caliper. This one is a Best Tool Canon, which I've never seen the brand before, but I think I paid the princely sum of like $35 on eBay for it. What's great about these is, I want to know the diameter of that shaft, right? So I just put them on it, and I can see that it is, and you probably can't, it is 625. It's 5/8. I would have thought that it was a ½ inch actually just looking at it. So now I know I need a piece of 5/8 rod, and I'll measure the other stuff. The other cool thing about this is that I also need a grip for right there, because you don't want to leave the cable just hanging out in there. It'll cut through. So you can see on this one, there's a clamp right there that holds it in place. So, but in order to get one of those, I need to know what size this hole is. So that's what this part of it is for. So you put this inside of a hole, and I mean on this, you could do it with a tape measure, but I'm just showing you all the ways this works at the moment. And it is 1 inch 7/52, so it's 1 3/4 inches. So now I know I need a 1 3/4 cable grip. If you go to the electrical section of Home Depot, kind of tell them what you're looking for. You'll then have to go find it yourself, but that's fine. The other way these things measure, because they measure in, 3 or 4 ways, is you can measure the height of something by putting that part on there and measuring down. And then I know that the height of that bolt head is like 0.234, 0.235. You can also measure down like this as well. And again, basically the same measurement. I get a little wobbling, and that's within 5 thou. I'd call this a plus or minus 5 thou tool pretty regularly. It's definitely not a tenths measurement tool. I much prefer the dial. You can get a vernier gauge, which is great, but until you get used to it, they're a lot of work to read a vernier gauge. But I guess they have a better potential for accuracy, and of course, they don't have any moving parts to break. And then you can also get a digital one, but the digital 12-inch size, and that's what this is a 12-inch dial caliper. The digital size is in this size is either more expensive or you got to buy a cheap Chinese one. This is at least a pretty reasonable quality hardened stainless tool. I like this because I can leave it in my garage, and when it's 0 degrees out, you know, it might measure a slightly different size due to expansion of the material, but it will measure, whereas a digital one might not give you a measurement at all. And of course, then when it dies, which will be at the least good time for you, convenient time anyways, when it dies at the least convenient time, you will go to your hardware store and they will not have the battery because you probably bought the cheap Chinese version instead of the Mitutoyo, because the Mitutoyo one of these is, I don't know, $500. Which again, if money was no object, I'd have 3 of them. But since money is an object, and this was on eBay, this was actually listed as a 13-inch caliper, even though it's only a 12-inch caliper because they literally measured it with a tape measure. So get creative with how you're looking at it. I'm sure that's why I got this for 35 bucks, because nobody else saw it. And again, don't spend a fortune on the one you're going to use in your shop. I'd kind of recommend, like, I have 2 6-inch ones of these. I have the one 12-inch. One of my 6 inches is like a shop tool, so I don't take too much care of it. I don't worry about it too much, and I use it pretty aggressively. And then I have one that's a Mitutoyo dial caliper, which I really like. But that one is sort of when I'm machining things, I use that, and I treat it a lot more carefully because that's how you should do it. We'll talk more about machining tools and measurement tools in later videos, but I just figured I'd bring that up because we were going to use it, and because now I know that I got a 5/8 shaft on there and all that goodness. So yeah, I'll have to cut out this stuff that I welded in earlier. I'll have to cut those, take those casters off. Part of me kind of wants to use them. They seem pretty beefy. It was a pretty heavy welder that was on here, but the welder was broken. I got out of trash basically, and it seemed great for my little suitcase welder, and it was until I got a better solution for that. So I might even use these and just bolt those to the bottom of these pieces of wood attached here after I tighten them up a little bit. See how that does. Maybe I have to go bigger. Obviously a bigger diameter is better, but these are also wider and much harder, so they won't pick up as much garbage. And then for the shaft, this material is pretty hefty, and as long as I have a straight through shot from here all the way through here and a long enough shaft, I should be fine. And in the case of this, they're already just using a cotter pin to hold it in place, so I'm not too worried about that. I've got the cable end terminations to put underneath there. I have the cable. This is 6/3 cable. So if you need to buy cable like this, find your local actual electrical supply company, because Home Depot charges like $4 a foot for this, and they did only have like I think it's 15-foot length when I went there of this, but it was like half the cost of what Home Depot would have charged, and it's exactly the same South wire Neoprene. You want to ask for like SO cable, just call it SO cable, they'll know exactly what you're talking about. It's SJOOW or SOOW, but if you just say, hey, I need some 6/3 SO cable to hook up a welder, they'll get you the right thing. Water resistant is also pretty important. Again, it's not gonna be sitting in a pool of water, but this is the right tool for the job. Now, why 6-gauge wire? Because this welder can pull up to 78 amps at full bore. Now, if you watch my other video, you might say, well, this is a 250 amp welder that pulls 78 amps at full load, and the other one's a 300 amp welder, and that only pulls around 30 amps or 35 amps at full load. So what gives? And well, it's all about the watts output, and power and watts equals volts times amps. The maximum voltage on that is 42 volts. The maximum voltage on this is lower. So because this outputs a lower voltage, like in the 20s of volts, it needs about twice as many amps as that to get to the same amount of power output. So yeah, because they use different voltages, and the other big difference is MIG welder is a constant voltage device, whereas a TIG welder, and again, and as such, the dial on the front, you set the voltage, and a TIG welder is a constant current device. Something that you might be more familiar with that's the same sort of thing is an LED is a current-driven device. So the voltage you feed an LED is a lot less important than the amount of amperage you feed it. We could go off on a huge tangent on that, but I refuse to. So anyways, that's the introduction to this welder. So what we'll see in the rest of this video is I'll go to Home Depot, I'll get the parts that I need to finish this, and then I'll put this back together the way that I want with the cable and everything, and I might even I'm gonna try to get something so I can put a handle around the front. I had these and I kind of had some thought, but they're sort of the wrong thing for the job anyways. We'll get the tank chained up, we'll get a tray for the tank, we'll get the big wheels on the back, we'll get the little wheels on the front, and when this is back on the floor, all the wires wrapped up properly. And you can watch me, clean up this mess that's I've been ignoring for 3 years. As my end goal is to park both of the welders there and there, right by the outlet, which is there. And then I've got this nice area where I can roll them out or in. And also I had a bunch of crap in front of my my tank, so I wasn't draining it as often as I should have. And of course now, because of the weather, it's all frozen up on the inside. So we'll get this set up, we'll clean all this up, and that will be that for this video. And I hope you enjoy watching it, because one of us should be having fun. Okay, I'm back from the hardware store. I got my 5/8 piece of shaft I'm going to use as an axle, and I got my, so this is a 1.5 inch clamp connector, and at some point I'm going to have a rant about trade sizes, and basically the end of it all is that trade sizes are just a ridiculous fiction that's made up to upset people, or based on stuff that's not even accurate at all anymore. Like 2x4s aren't 2x4s. Well, 3/4 conduit's not 3/4, 3/4 pipe's not 3/4. The only thing you know for sure is the name of the size has nothing to do with what it actually measures. In the case of this, I measured 1 3/4, and this is a 1.5 inch size, trade size connector, and it doesn't even go in a 1 3/4 inch hole. So I'm gonna have to open that up with my die grinder here. I'm gonna be drilling some holes for the axle shaft, and I don't have a 5/8 drill, so again, die grinder with a good carbide burr will go a long way. And yeah, that should do it. A note on carbide burrs like this. This one's MA Ford brand. You don't want cheap ones. This is actually, I think you guys can see it. There's a little bit of yellow there. It's actually a piece of carbide brazed to a tool steel shaft. These are great at removing material, but it's, oh, there we go, that's probably closer. It's very much a situation where putting more muscle into it is not the way. You gotta let them cut nice and slow. You don't want to put a lot of force in them, and you want a good air tool to drive them. But I'm going to do a whole video on air tools and why I have, at this point, switched over to Dynabrade, which is probably unnecessary, but I am sick of dealing with crappy air tools, and Dynabrade is great. I mean, they've even gone so far as to put the outlet on the front, so instead of freezing your hands off, it's blowing your chips away. I can't say enough good things about Dynabrade tools. They just work. All right, just some important information. Obviously, I'd like the bottom of this to be relatively level when I'm done. So what I'm going to do is pop off one of those wheels, take some measurements of it, take some measurements of the caster, and just do all the math. Figure out what height I'm going to put that hole in at. You know, I could just eyeball it, and maybe it would be okay, but I think we know it wouldn't be. Also, Home Depot is not a sponsor, though I wouldn't mind. Come on. There we go. So the little caster is 3.8 inches. And the thing I'm going to attach it to is it's a board that is 1.9 inches. All right. So the diameter of this wheel is 9.9 inches. You can call it 10 inches. So, inches. So, that math doesn't work out great for me. But there's a lip on the bottom. We'll bolt it to the bottom. So, instead, we'll get rid of the 1.9. We'll get rid of the block of wood across the front. I don't think it's doing anything. And if this is 10-inch wheel, that's 5 inches is half of the wheel, minus 3.8 is 1.2 inches. So we will have to drill that hole 1.2 inches up, which is about there. So it'll be drilled right about there. That looks like a good height. We don't want to go any lower. We'll take those off. Problem solved. And there is a nice wide lip that these can be bolted to, and I have all the nuts and bolts I need to bolt them. So problem solved. Actually, I got 9/16-ish. All right. What am I doing? The end for one of the cotter pins. Put the cotter pin, put the whole wheel together. If you saw me monkeying around, it's because I had the outside to the inside. The hubs stick more to one side than the other. So if I do that this way, I get clearance. Just rub on that a little bit. So now, rather than trying to measure and add all the stack up, I know where it's going to sit. And I know I can cut this off at about there. I'll give it like, I don't know, a little bit, some of an inch. And I'm just going to slide this off, grab an end grinder, whop it, drill it. I don't even take it off again. Because measurement's for suckers. No, it's not, but building it to reality will always work. Building it to a measurement will sometimes work. Now I want to point out that there's less than a 1/16 of an inch of play in this, even though I use no measurement tools at all, and you really want some play. If it's too tight, you're gonna just hate yourself when you're trying to fuss those cotter pins in, so. All right, that's 2 wheels done. 2 wheels to go. So, if I think this material could use strengthening, I have a couple of plates from the bottom of the tray that I can use to stiffen it up, but I think, well, thanks to the camera's battery dying, which and running out of memory space, both of which I suppose are actually my fault. I don't have any more video for the rest of this build, but we'll go through the finished product and I'll just show a little bit about what I did and why I did it. And yeah, I'm very happy with how it came out though. So we're gonna go over to the back end first, and we're gonna look at this. This is that tray. I don't know how to get this to, here, I'll pull the cord out of the way. There we go. This is that tray that was the cart previously. I did cut the width of it down and re-weld it back on, and then I welded a little grid here into it for the bottom of the tank, and then I put a bar across the back with a welded on loop to hold the tank in place, and then I screwed on this thing here to hold the power cord, which it more or less does, though a little bit less than more. But that's okay, because it does keep it in place and keep it out of the wheels and off the ground, and that's all I really wanted it for. I didn't mention this before. These wheels actually have, I'll get a light, a grease nipple on them. They are actually bearinged wheels, which is another reason I didn't mind running them on just a shaft like that, because the shaft isn't going to spin. I mean, when you roll it back and forth, you can see the shaft stays still. The wheels are spinning on their bearings. It is funny that it is a grease nipple though, because they're shielded bearings. Kind of an odd combination, I think, for something like this. But in any case, they certainly will do the job, and it does roll around really nicely. I have those, what look like itty bitty casters. I don't really mention it, but the reason I went with these is because the plastic is really, really hard, which means that it just won't get full. You can see that there's stuff stuck to it, but not into it. If you have a really soft caster, over time it'll pick up metal chips, and yeah, excellent lighting. It'll pick up metal chips, and the thing won't spin very well, and then you got to go pick them out. It takes forever. At the machine shop I work at, one of the jobs our summer interns do is sit there with files and file out the chips and pick the chips out of the wheels on the carts we use to push parts around. So I'm not going to do that. So this works out well. Let me get myself resituated and I can show you how I ended up mounting them. I felt that let me just smack myself with that. I felt that there we go. That the material for this box, part of the frame of this welder, is like 100 thou, 80 thou, probably, what, 14 gauge, something like that. It just didn't feel sturdy enough. So what I ended up doing is I took the plates from earlier that were part of the, yeah, there you go. You can see that plate there. That was part of the original piece, and I welded it, which you probably can't see because it's way in there. I welded it in there, and then I welded this little piece of just 1/8 inch flat across the front just to keep it sturdy. Yeah, and it worked out great. I even found almost all the fasteners that I dumped all over the floor. So anyways, now this thing rolls around well, which is really handy. So I can put it over in this corner, which you'll notice is actually pretty clean now. And we'll roll the other welder over next to it. And now, instead of having all my cables strewn about getting stepped on, they're wrapped up on their machines, taken care of. This is a much better way. So, yeah, really about it for this build. Oh, one more little thing. The TIG stinger. I took a piece of an old piece of airline, split it, and yeah, you might not even be able to see the split, but I split it right there with a razor blade, slipped it over and zip tied it in place. So now when I hang that there, even though this is plastic and this, it shouldn't arc, I know now that this won't arc like it did before, and that won't be a problem again. So I'd suggest doing something similar. You definitely don't want, well, you don't want a second arc anyways. It's gonna screw up your welding arc, even if everything else was fine with that. So that's about it. Thank you for watching this episode of Theoretically Practical. My name is Brent, and it kills me just ever so slightly to say this, but you know, please like, comment, and subscribe. Yeah, because, you know, everyone wants to quit their job, right? Have a great day.